Last time, we saw how we can use a for loop to execute a block or chunk of code a set number of times. This time, we'll look at nested for loops. So what are nested for loops? Nested for loops are when we put one for loop inside another for loop. What are they good for? They're most commonly used to process 2 or higher dimensions of data, though we'll see some other examples as well in the lectures in this lesson. Let's go take a look. The problem we're going to solve here is we're going to print out the multiplication table from 1 to 10. The first thing I want to do is print a table header, and I'll start using console write, not WriteLine, to print 5 spaces. And it will become clear as we work through this problem why I'm doing that. But now I can print the rest of the table header, which will be the numbers from 1 to 10. And of course I can use a for loop to do that. And I'm going to start I at 1 here, not 0. And I'll say I less than or equal to 10, and I'll increment I each time. And now I want to print, again using write, not WriteLine, I'm going to want to print I, but I actually want to put it in a field that's 5 spaces wide, including the I, so that my table looks nice. And the way I do that is I use something called a format string. The way the format string works is I put the format string between these double quotes, and then I say what I want to print out. My format string has curly braces on both sides. The first thing I put is which of the arguments following the format string do I want to print here, and I want to print the 0th argument. I only want to print this I. But the other piece that I can provide, and there's lots more, you can read about this in the book if you want to, but just to set the field width, I can say I want this in a field of 5. So it's going to print I in a field width of 5, including the value of I. When I'm done, because I'm just printing that row, I want to do a WriteLine. Let's run the code and see the table header. And there you go. So I have those 5 spaces at the beginning, and then I have 1 printed in a field of 5, and it's right justified. And by the way, if I made this -5 instead, then all those numbers are left justified instead, but I want them to be right justified. So I've used a regular for loop, right? There's no nested for loop here. This is a regular for loop to print the table header. Now I want to print the multiplication table. And here's where we'll get to use nested for loops. I'll start. And notice that this time, since I used I equal 1 in the previous for loop, it suggests I do I equal 1 here also, and I will. And I'll accept the rest of that too, because I want to do it the way I did above. I'm going to add spaces even though they weren't suggested there, and they're not necessary. Spaces are just what are called white space, and they're just improve readability. So now I'm going to print all the rows in the actual table. The first thing that should appear in each row is the I for that row, and I can right justify that as well. So I'll actually just grab this code right here, and that will print out I at the beginning of the row. I also know that at the end of each row, I'm going to want to have a console WriteLine. So let's actually see what this looks like when I run it. Okay, and that's the basic stuff for my multiplication table. All I need to add is the actual multiplication table. And here's where we get to use nested for loops. Before we do, I want to point out that this I is not the same as this I. The scope of this I, the places where this I here is visible, is right there. So if I actually tried to output I down here, I'll get a compilation error. It says the name I does not exist in the current context because this is the scope of I. So I is not visible outside that for loop. And that means that this I is a totally different I from this I, even though they have the same name. You might say, well, that's confusing. You should use a different loop control variable name down here. And you could. We've been using I, but you could call it Bob or Mary. But it's pretty common to use I as our loop control variable. So it's not really confusing to most people who are used to dealing with for loops. I will say, though, that here we want another for loop. But you'll notice I get a suggestion that we use J here instead of I. And we're going to take that suggestion. That's a great suggestion, so we'll do it. And I like the rest of that suggestion too, so I'll just take it. If we use I here, that's going to be a problem because the scope of this I is here. So if I try to use I here, the compiler will say you already have an I that's in scope here, so you can't use the same variable name twice. It's also really common to use J as our loop control variable for a loop that's nested inside a loop that uses I. So now we'll actually just print out the multiplication table part of this particular row. We're only working on one row right here. So I'll console and I'll use write. And here I'm going to again use a format string to output in a field of 5. And now I need to output the product of I times J. And we'll talk about how this works in just a moment. I think I'll get rid of this extra white space. I'm just printing each row here so I don't need to separate those chunks of code. Let's look at the output and then talk about how it works. And there you go. That's the multiplication table. You can convince yourself that this is a correct multiplication table, but it certainly is correct. So how does this all work? When we get to this for loop, we set I to 1. We make sure that I is less than or equal to 10, and it is. So we come down into the first row and we print 1. Now we get to this for loop, and J gets set to 1. And 1 is less than or equal to 10, so we print 1 times 1. And we come back to the top of this inner for loop. We make J2. 2 is less than or equal to 10, so we print 1. We haven't changed I yet, but we have changed J to 2, so we print 1 times 2. We come back again, set J to 3. 3 is less than or equal to 10. We print 1 times 3, and we do that until this for loop is done. In other words, once we increment J to 11, 11 isn't less than or equal to 10, so we're done with this for loop. We do our write line so that we move to the next row, and that's the end of the body for our outer for loop. So we come up here and change I to 2. 2 is less than or equal to 10. So we print 2 at the beginning of our row. And now we get to this inner for loop. And this inner for loop has no memory that it ever ran before. So when we get here, we just start it fresh, like it's never been executed before. So we set J to 1. 1 is less than or equal to 10. So we print out 2 times 1, which is 2. And then we set J to 2. 2 is less than or equal to 10, so we print 2 times 2, and so on. So that's the part that sometimes confuses people with nested for loops, that when we get here, it's brand new. It's not continuing from the last time we ran this nested for loop. This is sort of getting to it for the very first time from the perspective of this for loop. You can think of this as wheels within wheels, if you'd like. So we have this outer wheel that we start, and then we spin this inner wheel, and when we're done, we forward this outer wheel 1 tick, of a revolution, and then we spin this inner wheel again, and then we just keep doing that. So that's how we can use nested for loops in C#. To recap, in this lecture we saw how to use nested for loops to solve a problem.